All right, let's take a look at practice test 2. Number 1, we're in some of the geometry stuff. It says given the following figure of a tabletop, find the circumference. And really importantly, it tells us for pi, we're going to use 3.14. So we're just going to estimate pi. That will change your answer a little bit. If you use the pi key on your calculator, Hawks is going to count it wrong. I'll see it when I go through the problems when I'm grading the test and fix it. But just so you know, if you forget and use the pi key on your calculator, Hawks is going to count it wrong. So try to remember to just use 3.14. Okay, so it says find the circumference. So then I've got a formula sheet on Canvas that you can use. Okay, so for circumference, we want the circumference of a circle. There's two ways we can think about it. We can either think about it as 2 pi r, or we can think about circumference as pi d. Okay, calculate it either way. This one is the one I have on the formula sheet. It seems like that's the one I end up using the most in practice. So that's just the one I've got on there. You can do it either way, but the thing that would choose the formula for you is what information you're given. So on this one, we're given this 30 centimeters from the center of the circle to the outside of the circle. So since it goes halfway across the circle, that is r, our radius. If it went all the way across the circle, the number we were given all the way across the circle, that would be diameter. So we would use the other formula. So on this one, we're given the radius. So the easiest way we can get there is using the formula on the left. So for circumference, it's 2, and then for pi, we're using 3.14. And then for the radius, we're using 30. Okay, so let me grab my calculator. Okay, so if we do 2 times 3.14 times 30, I'm getting 188.4. It tells us to round to the nearest hundredth if we need to. That would be 2 decimal places, so we're good here. We can just leave it 188.4. And then our units were centimeters. So for circumference, they're not square units or cubed units. It's just the regular old units here. Okay. Look at number 2. Okay, number 2 tells us we've got a swimming pool with the following shape. The homeowner wishes to create a canvas cover for the pool. How many square feet of canvas would be required to cover the pool? Okay, so since we're talking about square feet here and we're trying to cover up the pool, we're dealing with area. Okay? So on this problem, probably the easiest way to attack it is we don't have you can use like the area of a trapezoid if you want to do it that way, but I think to me it's a little bit easier if we use the area of a rectangle, so we can find the area of this rectangular part, and then the area of a triangle, we can find the area of this triangle part. Okay? So and then we can add those two together. So if we're doing the rectangular part, the red part, then our formula for area is just length times width. And it doesn't matter which one you call length, which one you call width. So 13 times 16, let's see what that gives us. That's 208. And we're in feet. And since we're dealing with area, it's feet squared. Okay. Now let's do the triangle. Okay, so the area of a triangle, 1/2 times the base times the height. Okay, so we're going to have 1/2. Our base here is 15. And the height is the same as the side of that square, is 16 feet. So let's see what we get there. And the way I'm going to put it in my calculator is I'm going to do 15 times 16 equal, and then divide that by 2. You can use the fraction button if you want to. And so there I'm getting 120. And that's going to be feet squared. Okay. So now we're going to add these two together. So 208 square feet plus 120 square feet gives us a total area. What is that? 328. Oops, sorry about that. So 328 square feet. Okay. If you wanted to do the area of a trapezoid instead. Area of a trapezoid is 1/2 times base 1 plus base 2 times h. So what you would have to realize is that the base down here, you have to add these together, so that would be 28 feet. And then the base at the top would be the same as the square part down at the bottom, so this would be 13 feet, and you could use this area of a trapezoid formula and get the same answer. But either way is okay. To me, I just like thinking about rectangles and triangles when I can. Okay. Go to number 3. Alright, number 3. This is a formula I forgot to put on the formula sheet on Canvas. I will add this formula and re-upload the formula sheet. But this says find the sum of the measure of the interior angles of a 25-gon. That's a 25-sided polygon. Okay, so the sum of interior angles, that's the angles on the inside of the polygon. So if we have an n-sided polygon, our formula there is n minus 2, so however many sides it has, minus 2 times 180 degrees. Okay, so here, this is a 25-gon, so n is 25. So if we do 25 minus 2 times 180 degrees, now what's that going to be? That's going to be 23 times 180. Get a big number here. Sum of the interior angles of this 25-sided polygon is going to be 1,440 degrees. Okay, so I will go back and put this formula on the formula sheet, okay, for the test. I just forgot to put it on there. Okay. Number 4. Number 4. Okay. Tells us a rectangular piece of land has dimensions of 400 feet by 150 feet. Find the area of the land to be enclosed by the fence. Okay, so it says we've got a rectangle. Helps to make a little sketch sometimes. It says it's 400 feet by 150 feet. And we want the area, so what we're looking for is we're looking for how much is in here. So we've actually already used this formula. This one's the easy one. It's just length times width. A lot of you will remember that. So, and it doesn't matter which one you call length, which one you call width. Okay, so we'll do 400 times 150. Okay, so let's see what we get there. So we get a total of 60,000. Our units were feet. And since we're working with area, we're going to have square units. So square feet, 60,000 square feet. Okay. Number 5. Moving into 3 dimensions here. So be real careful. We've been doing area. This one wants the volume of the figure. So we have to figure out what type of shape we're dealing with here. So you could call this one, you could call it a box. Or you could call it a rectangular solid or a rectangular prism. Okay, so our formula for volume of a rectangular solid, a rectangular prism, is length times width, and then we're adding one more dimension, we're adding height. Okay. And again, it doesn't matter which one you call which. And just make sure you get them all 3 in there. So I'm going to call our length 10 yards, our width 5 yards, and our height 6 yards. Okay. And then we multiply those together. We get 300. Our units were yards. Okay. And then since we're in 3 dimensions, we have cubic yards. So 300 cubic yards is our volume here, and how much space it would hold. 300 cubic yards. Two more on this video. Number 6 says find the volume again. So we're working in 3 dimensions. This time, what would we call our shape? We would call this a cylinder. Okay, so we got 2 flat ends, and then if we look at it from the top down, it looks like a circle. And so we've got a cylinder. So, and again, it tells us for pi, we're going to use 3.14. Okay. So if we want the volume of a cylinder, then that's 2 pi r squared h. Okay, again, we're taking the volume of the circle end, and then we're multiplying it by how tall it is. So 2 pi r squared h. So, and it's not 2. Sorry about that. It's just pi r squared h. And I mixed my circumference and my area formulas together there. So it's just pi r squared h. Okay. So if we fill in our numbers here for pi, we're using 3.14. Our radius, and our radius is halfway across the circle, so that's 10. We want to square that, so times itself. And then our height is 11. So let's see what we get here. 3.14 times 10 squared. 10 times 10 is 100. Times 11. 3,454. Our units were centimeters. And we're in 3 dimensions, so we're going to have 3-dimensional units. So centimeters cubed to the 3rd power there. One more. Try not to mess this formula up like I did the last one. Okay, so find surface area. Personally, I hate finding surface area, so I'll give you an easy one here. Okay, what kind of shape would we call this? Well, it looks rectangular, but if you pay attention to the numbers, the length, the width, and the height are all the same number. Right, so if we've got the same length on all the dimensions, we call that a cube. Right? So surface area of a cube is about the easiest surface area formula I could give you. Okay. So for surface area, we're thinking like how much wrapping paper would it take us to cover this shape. Okay, we're just trying to cover the outside up. So it's a 3-dimensional area. It's a little weird. Okay, so what do we got here? Well, if we were thinking about the area of just one of these squares, right, it would be length times width, so it would be 17 times 17. Okay. So to figure out how much area we have on one of these faces, we would call that side squared. So 17 squared. And then we have to figure out how many faces we have. So we've got front, back, left, right, top, bottom. So we've got 6 of those. They're all going to have the same area, so we just multiply by 6. So 6 sides squared. So here we want 6 times 17 yards squared. So let's see, 17 squared, 289 times 6 gives us 1,734. We're in yards. And this is a little tricky. We've got a 3-dimensional shape, but we're just finding the area of the surface. So the dimension of the number we've got is area. So it's going to be square yards. So 1,734 square yards.